Hello, welcome to part 2 of the section about the quadratic formula. To begin, I would like to go back to quickly this stage in our working in the last section where we derived the quadratic formula. We ended up at x plus b divided by 2a squared is equal to b squared minus 4ac divided by 2a squared. And we're trying to solve this thing for x. We're trying to find the value of x, which makes this equation true. And to do so, we said, well, okay, if this thing squared is equal to this thing, well then let's go ahead and take the square root of both sides. If we take the square root of the left-hand side, well, that squared cancels out, so we just end up with x plus b divided by 2a. And if we take the square root of the other side, well, that's when you square root a fraction, it's the same as taking the square root of the numerator divided by the square root of the denominator. So we can write that as square root of b squared minus 4ac divided by square root of 2a squared. Now remember, the square root is always positive. Whenever you put something into the square root function, you should always get something positive out. However, that's a problem because we actually have no idea whether x plus b divided by 2a is positive or negative. And hence, what we need to do to this side is take both the positive and the negative values, both the positive and the negative values of it. So that's actually two possibilities, because this thing here can be either positive or negative. Let me give you an example. We know 5 times 5 equals 25. So if x was equal to 5, then x squared equals 25 is true. But also, we know negative 5 times negative 5 equals 25. So we have x could be 5 or x could be negative 5. It could be the positive or the negative. So 5 is equal to the positive square root of 25. Negative 5 is equal to the negative square root of 25. So both of those are possibilities, and hence we need to take both the positive and the negative square roots of this side. Let me clear some space. Okay, what about the sign of a though? So we said, what we ended up saying in our working was that this is equal to plus or minus the square root of b squared minus 4ac, and then we divided it by just 2a. Square root of 2a squared is equal to 2a. Is that a problem? It kind of looks like it should be a problem because, well, the square root of negative 5 squared is equal to the square root of 25, which is actually equal to positive 5. So the signs swapped over. Well, actually, in this case, it doesn't matter because we're taking both the positive and the negative values. We're taking both the positive and the negative values. So if a did have a negative sign, then, so like if a had a negative sign, negative, then it doesn't matter because this negative here and this negative here would cancel and we'd get a positive, but also the negative and the positive would make a negative. So you're still going to end up with both the positive and the negative value. So it actually doesn't matter about the sign of a. That's fine. What does matter, however, is this b squared minus 4ac term. What does matter is that one. Can anyone see a problem with it? Can you see a problem with, or a potential problem with b squared minus 4ac when you take the square root of it? Well, it's kind of the same problem as before. What is the square root of negative 25? Well, the square root of negative 25 is some number such that when you times it by itself, you get negative 25. Well, 5 times 5 equals 25, but also negative 5 times negative 5 equals 25. So what's the number x such that x squared equals negative 25? Well, there is no such x in the real numbers actually. So when b squared minus 4ac is actually less than 0, then there are no values of x which satisfy our quadratic equation. Let me write that down. Clear some space. If b squared minus 4ac is less than 0, there are no values of x that make ax squared plus bx plus c equals 0 true. There are no values of x to make that equation true if b squared minus 4ac is less than 0. And the reason for that is because you'll get a negative number in here, and you can't take the square root of a negative number. There are no real numbers that will come out of the square root. So that is a problem. We cannot get solutions for that. Let's do an example of what I mean here. So let's take x squared minus 4x plus 6. Equals 0. What happens when we try and put that into the quadratic formula? X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Our a in this case is 1, our b is negative 4, and our c is positive 6. Well, negative b is therefore negative 4, so we get x equals negative 4, which is just 4, plus or minus the square root of b squared, so negative 4 squared, which is 16, minus 4 times 1 times 6, 4 times a times c. Well, 4 times 6 is 24, and that's all divided by 2a, which is just 2. So we get 4 plus or minus the square root of 16 minus 24, so square root of negative 8 divided by 2. Oh dear, what is the square root of negative 8? Well, that's a problem. We can't take the square root of a negative number, and hence there are no solutions. We actually we usually write no real solutions. No real solutions, because there are no real numbers. Remember, the real numbers is the line of all the numbers are. There are no real numbers to make this equation true. So there are no real solutions when b squared minus 4ac is less than 0. Because remember, this part in here is actually b squared minus 4ac. It's negative 4 squared minus 4 times 1 times 6. So 16 minus 24, less than 0. No real solutions. Okay, let's, remember what we said last time. This is actually, we can actually think of this as a parabola. Y of x equals x squared minus 4x plus 6. Well, let me write that again. Y of x equals x squared minus 4x plus 6. Let's see what happens when we actually draw this thing. It's kind of hard to draw because it's in the ax squared plus bx plus c form. So let's go ahead and complete the square on this. If we complete the square, remember, completing the square means we should factor out a. Well, a is already 1, so we actually don't even need to factor that out. So let's just divide our b term by 2 and then square it and add that and subtract it. So the b term divided by 2 is negative 4 divided by 2, so negative 2. And then negative 2 squared is 4. So plus 4 minus 4. So this is equal to x squared minus 4x plus 4 minus 4 plus 6. And now, because we completed the square, we know that this part here should be a perfect square. We should be able to square that. And indeed we can, because this is equal to x minus 2 squared. And then we still have minus 4 plus 6, which is plus 2. Okay, so now this thing's actually pretty easy to draw. We can draw this from our section on parabolas. Let's go ahead and do that. This is the x-axis, this is the y-axis. You should always label your x and y-axes. I know I get kind of lazy sometimes, so I don't bother, but in general you should. Okay, now x minus 2 squared. Well, that means we go 2 across to the right, because this thing should be equal to 0 when x is equal to 2. Well, this little section of it should be equal to 0 when x is equal to 2. So we go 2 across to the right. Let's say 1, 2. And then we're adding on 2, so that means we go up by 2. 1, 2. So the turning point of our parabola is right there at the point x equals 2, y equals 2, and the k value, or the a value, whichever letter you like to call it, is 1, and so our parabola looks pretty much like that. And it goes off forever in that direction and forever in that direction. Well, in particular, where does this thing cut the x-axis? Where does this thing let y equal to 0? Where is this thing equal to 0? Well, nowhere. If it was equal to 0, then it would cut the x-axis, because this blue line is the line y equals 0. So this equals 0 along that blue line. But this thing doesn't even touch the blue line, so it's equal to 0 nowhere. And that explains why we can't get any solutions. Why we can't get any solutions of this thing equals to 0. That's why there are no solutions, because the parabola doesn't even touch the x-axis. And the x-axis is the line of, well, where if it did touch that line, that's where the function would equal 0. Okay, so b squared, let me say it one more time just for fun. B squared minus 4ac less than 0 means no solutions, because the parabola doesn't even touch the x-axis in that case. Okay, well, let's do another case. What about b squared minus 4ac equals 0? So b squared minus 4ac equals 0. Remember, given a quadratic equation of the form ax squared plus bx plus c equals 0, we know that by our quadratic formula, x is equal to two things. It's equal to negative b plus the square root of b squared minus 4ac divided by 2a, or it's equal to negative b minus the square root of b squared minus 4ac. Well, if b squared minus 4ac equals 0, then all it is just negative b plus or minus the square root of 0. Well, square root of 0 is 0. So it's actually just equal to negative b plus or minus 0, negative b, divided by 2a. And so when b squared minus 4ac equals 0, we only have one solution. One solution. There's only one value of x to make this thing true, and that value of x is negative b divided by 2a. So that's when b squared minus 4ac is actually equal to 0. There's only one solution that comes out of this thing. Let's do an example. Let's take let's consider x squared minus 4x plus 4. All I did was take away 2 from our last example. Let's suppose that this thing is equal to 0. Well, if we chuck in our values, we get x is equal to negative b, so negative 4, so that's 4, plus or minus the square root of b squared minus 4 times a times c. So negative 4 squared is 16 minus 4 times 1 times 4, so minus 16 divided by 2 times 1, so divided by 2. And so we indeed get x is equal to b plus or minus 0 divided by 2, well, divided by 2a. And so that's 4 divided by 2, which is just 2. So we only get one solution. X is equal to 2. Let's find out why. Let's go ahead and draw this as a function of a parabola. Y of x equals x squared minus 4x plus 4. And, well, I can just observe it, and the fact that there's only one solution means this must be true anyway. This thing has to be a perfect square, and it's in fact equal to the perfect square x minus 2 times x minus 2, or x minus 2 squared. And that's very easy to draw. The a value is still 1, so we don't have to worry about how fat or thin it is. It's just regular. So if we draw this thing, draw it over here. This is the x-axis, this is the y-axis. If we draw this thing, here's 1, here's 2, x minus 2 squared. It's exactly the same as the graph x squared, which looks like this one, except it's been shifted across to the right by 2. And it just touches the x-axis once. Maybe use blue. Just touches the x-axis once. Remember, wherever the parabola touches the x-axis, that's the value of x to make it equal to 0, because this x-axis is, of course, the line y equals 0. Y equals 0 along that line. So this thing is equal to 0 only when x equals 2. And hence, let me say it one more time just for fun, b squared minus 4ac equals 0 means only one value of x. Does b squared minus 4ac actually equal 0 here? Yeah, of course it does, because b squared is negative 4 squared. Negative 4 squared is 16, minus 4 times 1 times 4, so minus 16. So negative 4 times negative 4, 16, minus 16, of course that equals 0. So we know that there's only one value of x when x equals 2. And we know that when b squared minus 4ac is bigger than 0, then you're going to be adding and subtracting something to x. Well, if b squared minus 4ac is bigger than 0, then we know the square root of b squared minus 4ac is also bigger than 0, and hence x equals negative b plus the square root of b squared minus 4ac divided by 2a, or x equals negative b minus square root of, hope I don't run out of room, b squared minus 4ac divided by 2a. These are two different solutions. We're adding something positive onto negative b, or we're subtracting something positive from negative b. So when b squared minus 4ac is bigger than 0, we get two real solutions. Again, we use the word real here because we're talking about solutions on the real number line, that big infinite line called R. Okay, this b squared minus 4ac actually has a name. We call this thing, well, triangle is the symbol for it, and it's called the discriminant. It's called the discriminant. The reason why it's called the discriminant is because it discriminates between different quadratic equations. So it discriminates ax squared plus bx plus c equals 0. It puts them into three categories. The first category, number 1, b squared minus 4ac bigger than 0. Then we know that there are two real Solutions. Another word for solutions are roots, two real roots. The root of the equation is the solution of the equation. Maybe it's called root because it cuts through the x-axis at that point. I don't know. But two real roots. The second category, b squared minus 4ac equals 0. We know there is only one real root, or one real solution. And finally, the third category, b squared minus 4ac less than 0. We know that there are no real roots. No real roots. That means no solutions to the equation. So this discriminant discriminates, which means put into groups, categorize. So it discriminates this equation into one of the three groups, 1, 2, 3. Tells us whether it has one real root, no real roots, or two real roots. So just by looking at an equation of the form ax squared plus bx plus c equals 0, we can immediately know from the discriminant whether or not there are any solutions or more than one or whatever. You get my point. Okay, thank you very much for watching. I think that's it for this section. Don't forget to download the notes and have a go at the exercises at the end. Yeah, thanks again for watching. Take care. See you next time. Bye.